Welcome to this NPTEL lecture on principles and techniques of modern radar system. Now, we were discussing MTI filter. Out of that, we have seen that there is a good MTI filter, that is the one recursive filter with feedback loop. So, that one gives you a good passband response and also deep notch. Now, we will see that how we can extend the first blind speed with the radar without disturbing the lambda or FR. So, that we will discuss, that is called multiple PRF MTI. So, now to understand the concept, first thing that there are two pulse radars with different PRFs. Suppose PRF FR1 and another PRF is FR2, and they are trying to detect a target. So, obviously, since this is one radar, radar 1, and this is another radar, radar 2, they are trying to detect the same target. So, obviously, the first blind speed of this radar is different from the first blind speed of this radar, because their PRFs are different. Now, even if they are operating at same RF frequency, their first blind speeds are different. So, target undetected by one radar may be visible to the second radar or vice versa, provided this FR1 and FR2 they are not integral multiples of each other. That means, FR2 should not be, if this relation holds, then if one misses that, the other will do that. So, that we can employ, but this is a costly affair, having to detect one target, one radar itself is costly, then putting two is costly, but this concept can be used, that the same radar, let us multiplex the PRF in time domain, multiplex the PRF in time domain, that is called multiple PRF MTI radar. Now, so we can say that instead of two radars, one radar can multiplex the two PRFs. Now, there are various ways by which this can be done. So, we can say PRF switched, PRF can be switched. One scheme is between scan, that means in one scan, antenna scan. So, in one scans the PRF is something, and the next scan it is a different PRF. Then some radars they do it between duals. Duals means when you are at a particular beam width, that means when you are scanning one beam width scan is called dual. So, every time the antenna scan half beam width, the PRF is switched. So, next PRF, another PRF is there, or the another scheme is between pulse. So, after sending one pulse with a particular PRF, the next pulse is a. So, this one we will discuss, the others are similar, the concept will. So, this is called switching PRF pulse to pulse, this is called staggered PRF. Okay. So, we will discuss this. So, one thing is that we will choose the PRFs in such a way that second pulse will be sent at, suppose one pulse is sent after an interval t is equal to t1. So, a first pulse is sent at t is equal to 0, then the second pulse is sent at t is equal to t1, then the third pulse is sent at t is equal to t1 plus t2. If we did not stagger, every pulse will send t is equal to t1 will send one pulse, t is equal to 2 t1 will send a pulse, t is equal to 3 t1 will send a pulse, but here you see that the first pulse we are sending at t is equal to 0, t is equal to t1 we are sending the second pulse, t is equal to t1 plus t2 we are sending the third pulse, and we are choosing so that t1 and t2 they are not integrally related. That means t1 by t2 will be n1 by n2, where n1 and n2 belongs to an integer, and also no common factor between n1 and n2, obviously except 1. 1 is common factor of every number. So, no common factor between n1 and n2. So, I will now to draw the graph I need some numbers. So, let us take one example is n1 is 4 and n2 is 5. So, what will be the magnitude response of the first one? So, I know that one sec. So, this will be if I draw, this is 1.0 and this side is f by fr. So, I can draw this, or let me fix it. So, n1 is 4. So, we are considering a single DLC. So, I know that it will be something like this, that there will be a notch here. So, this will be the thing. Now, what happens for the second one who has this n2 is equal to 5, what will be the response? So, let me so there we know that so the response of the two things, that means had we been the first one, that will give this, the second one with n2 is equal to 5 will give this response. So, if we now sum these two, you will find, actually this is a good MATLAB exercise, you yourself can do it and see that in this case the when we will see the staggered one, basically will show that this will be all these notches, that means these nulls, they will go, but before that we need to have some analysis. So, I will later complete this part, that how it will look with a staggered PRF, but we need to understand, and this ratio k is equal to n 1 by n 2, that is called a stagger ratio. Now, this choice of the stagger ratio is very important. Lot of theoretical work goes on to find out what is the stagger ratio. I will indicate that still there are some open research problems in this, how to choose these stagger ratios, etc. So, what I did, consider a 3 pulse canceller with PRIs. You know, this T1, T2, I have already introduced that those are called PRIs. So, with PRIs, the first one I have shown, that is having a PRI of T1 and the second one with a PRI T2. So, if we have that, so that means I have a, I can say one SDLC with PRI T1 and then another SDLC with PRI is T2. So, this will make a 3 pulse canceller. So, we can easily write what is the impulse response, that it is delta t minus delta t minus T1, then delta t minus T2 minus delta t minus T1 minus T2. So, we know it is delta t minus 2 delta t minus T1 plus delta t minus T1 minus T2. So, here you can put a change of variable, that u is equal to t minus T1, and that will make that your Ht is delta u plus T1, sorry, minus 2 delta u plus delta u minus T2. So, this one also we need to change, H u plus T1 is equal to this delta u plus T1 minus 2 delta u plus delta u minus T2. So, then we can go to the Z transform, that what will be the Z transform for this, that Hz z to the power plus T1 is equal to z to the power T1, this will be minus 2 this will be z to the power minus T2. So, this we can manipulate and easily find what is Hz. Hz will be 6 minus 4 cos, or I can write directly in terms of omega also, because we know how to come from z domain to this 2 pi f t1. Instead of omega I am writing, so this also I can write in terms of f. Four cos 2 pi f t1 minus 4 cos 2 pi f t2 plus 2 cos 2 pi f t1 plus t2. So, we can normalize this with this DC value 6. So, I can write h f square normalized is 1 minus 2/3 cos 2 pi f t1 minus 2/3 cos 2 pi f t2 plus 1/3 cos 2 pi f t1 plus t2. So, this thing now I am in a position to plot it. So, this plot now I can complete that. This is my level 1. So, this is my, I can say that h f square of the 3 DLC staggered. So, I will write staggered one. So, these two are there. So, let me take this color and for that let me take 0.1, 0.2, 0.3, 0.4, 0.5. Actually, in MATLAB you can do this well, but I am just giving you roughly an idea that how it looks like. That starting from here, actually it has something here, then again a local null here, then it goes up and 0.25, then 0.4 it has a null, then 0.5 again it has a null, then it will go up and again at 0.6 it will have a null, then 0.75 it will have a null, then finally it goes and comes to 1. Why you see what I have seen these are the points of null. So, when they are added, actually since nulls are a, so when you are cascading them, so at 0.2 there is a null, at 0.25 there is a null, local nulls, but you see the whole thing is making it more uniform, and by that it is the null, instead of having at 0.25, 0.5 etc., you are putting it much ahead. So, this is the first blind speed coming, and we will find out that how much improvement we have got compared to the original ones. So, at least there you can see that if whatever was the PRF of any original one, at least by 4 or 5 times or their LCM times it has been shifted. So, this shows that obviously one thing is it is not as uniform as the original one, but it has some local nulls here. But we know the technique that if we put the proper recursive filter, then this thing can be easily A, because if we could have make that sine square type of thing uniform. So, this is making uniform is not a problem with the recursive filter. So, with the recursive filter this thing is done. Now, the question is how far we have advanced, that means how far we are successful in pushing the blind speed. So, that will now calculate that first blind speed will occur when I can say from that graph that N1 by T1 is equal to N2 by T2 is equal to FR staggered. That means, basically when the nulls are coming, that some integral multiple of 1 by T1 and some other integral multiple of 1 by T2, when they are equal, then the null is coming, as in this case with 4 by 5. So, it will come at that 4 into some number and 5 into some number, we know that is the 20. So, at 20 it will come. So, here it is, this is the general thing. So, we can say that the what is FR staggered, you see very simple relation N1 into what is 1 by T1, it is the PRF of the first one, that means the PRF with which the radar operated at the first between the on the second pulse, that is this, or it is also same as N2 into 1 by T2 is nothing but FR2. So, how far it has pushed, either N1 times it has pushed or N2 times it has pushed, and in our case if we now specialize for that, that in our case we can say that FR staggered is nothing but 4 FR1 or 5 FR2, and so 4 FR1 is 5 FR2. But in general, now what is the general thing for this, that in general, suppose here we have assumed in the previous example only 2 PRFs we are multiplexing. Now, in many cases you need to multiplex more to push it further. So, let us say that there are capital N number of PRFs are there. So, we know the equation will be N1 by T1 is equal to N2 by T2 is equal to N3 by T3 is equal to Nn by Tn. So, this relation will hold. So, we can find what is the first blind speed. So, from here we can find what is the staggered PRF. So, any one of this is the staggered PRF will come the first blind speed, and from there we can find out what is FR staggered. As before, you can see the same equation we are writing, F staggered is any of them. So, FR staggered will be N1 FR1 or N2 FR2 etc., up to Nn FRN. Now, how much we are successful, to compare that we can say that compared to a constant PRF radar, how much this multiplexing of PRF has pushed the change. So, from staggered, what is the relation to the blind speed? So, V B or V blind first staggered. So, we know what is that relationship, that is lambda by 2 into FR stat. This lambda is the RF carrier frequencies lambda. So, FR stat. So, that means if we can make FR stat more, blind speed will be also small. Now, to compare it with a constant PRF, we need to find the average time, because you see different pulses have been sent on different time. So, we will have to compare it with a average time. Now, this T average is nothing but can be written T1 plus T2 plus T3 plus Tn by n, and we can say that a radar operating with a PRF which is average of these, that will be nothing but 1 by T average, and so it is V blind first average, that will be this lambda by 2 FR average. So, if we do that, so we can make the relation that V B or blind, V blind first stagger is nothing but N1 plus N2 plus Nn by n into V blind first ever. So, this number by which we are getting the improvement. So, this number is our improvement factor, that staggered, this staggered one compared to a constant PRF is how much. Now, we will derive this relation now. It is very simple. How I am coming from here to here. So, I will say also this average taking, actually there are two ways the average can be taken, they give slightly different result. This either you can take the average of PRIs or you can take the average of PRFs. Now, they give slightly different values, but more or less things are same. So, I will now, or I left it that you can do it. I am just giving you the result. In the example, we will see, or assignment you will have to derive this. So, I am writing that if you take the average for the constant PRF radar, average of the T average, average of, sorry, I will write average of PRI, then your improvement, that V blind first staggered becomes N1, whatever I have written, this is, we have this you can show that, but if I have average of PRF That means, if we have take some other, that FR average is FR1 plus FR2 plus FR capital N by N, then if you do, you will see that V blind fast staggered is equal to, the formula is N by 1 by N1 plus 1 by N2 plus 1 by Nn into this V blind fast average. So, you see these two formulas are slightly different, but any one can be used, as in the practical assignments. In the examples we will see that any one PRF you can use. So, for making the comparison, and there you will see that it is an order of improvement higher, that we can push the blind speed further. So, that completes our discussion on the putting the blind speed, etc. Now, we will have to find what is the composite a thing, because I have not shown you that how I have done this graph, that how to in general how to find the HF. Actually, you see that this graph I have, this expression I have derived for multiplexing two PRFs, but in general if there are more number of PRFs, then how to do that. Also, one thing I am not going into, that how to choose the numbers N1, N2, because choosing those numbers that they do not have common fraction, but you see choosing them gives you the actual multiplication factor. So, how to choose that? There are various theories, we are not going into that, but in the next class we will continue this discussion, and we will find for staggered PRFs how to find the some properties of PRF, and then we will also define various figure of merits for the this MTI filters, particularly MTI improvement factor, that we will find out, and we will then compare all these things, that how much clutter they are attenuating, and also how much signal they are attenuating. Basically, some sort of SNR type of thing, that will, that type of concept we will see, and we will make that performance evaluation, and from that we will see. So, that we will complete. So, MTI filter will be considering, but what we have seen in this lecture and the previous lecture, that what is an MTI filter made of, how to make a good DLC with feedback circuit, so that your passband thing is uniform. Now, we have seen how to extend your blind speed, and then we will see that if we go on multiplexing, etc., how that improves the blind speed reduction, blind speed extension, and then we will see some parameters which will evaluate quantitatively that how good our MTI filter is. Thank you.